All right, moving on to number 3. It says Chen measured his height and found he was 156 centimeters tall. Dwayne is 1.70 meters tall. Express the ratio of Chen's height to Dwayne's height as the simplest whole number ratio. Now the problem here is, though, that if we're taking Chen's height over Dwayne's height is in centimeters and Dwayne's height is in meters. So what we need to do here is we either need to convert Chen's height, the 156 centimeters, to meters, or we need to convert Dwayne's height of 1.70 meters to centimeters. So I'm going to go ahead and I'm going to convert Dwayne's height of 1.7 meters to centimeters. And it gives me a hint right here. 1 meter is 100 centimeters. So I want to cancel out my meters. So I'm going to put that on the bottom. Put the 100 there. So really what I'm doing here is I'm taking 1.70 times 100, which ends up being 170 centimeters. So now what I'm going to do is rewrite my ratio with both of them having, oops, sorry, that's 170 centimeters. And now I need to go ahead and simplify this. So one thing I notice here is that they are both even numbers. So I know even numbers, I can divide those by 2. So I'm going to go to my calculator. 156 divided by 2 is 78, and 170 divided by 2 is 85. So again, if I take both of these divided by 2, I'll get 78 over 85. And actually that's as far as that ratio, I'm sorry, is going to simplify. So we will just leave it right there. Okay, moving on. Number 4, in 2012, Australia's population was approximately 22,870,000, and the population of the United States was approximately 313,260,000. The land area of Australia is approximately 7,800,000 square kilometers, and the land area of the United States is approximately 9,630,000 square kilometers. So A, it says use a calculator to find the ratio of the population of the United States to the population of Australia. Write the answer as a unit ratio rounded to 1 decimal place. All right, so for A, I want to take the U.S. population over the Australian population. So if I go and look, the U.S. population right here, 313,260,000. Okay, I want to take that over the population of Australia, which was the 22,870,000. Okay, and I want to write that as a unit ratio, so I know that's going to be over 1. So I go to my calculator, and I type in the population of the U.S., so the 313,260,000. I'm going to divide that by the population of Australia, which was 22,870,000. And my answer will be what goes on top. Now it says round it to 1 decimal place, so it's 13.69, so the 9 is going to round the 6 up. So we're going to round that to 13.7. Okay, so that means there's 13.7 people in the U.S. for every 1 person in Australia. Okay. Now for B, it says use a calculator to find the ratio of the land area of the United States to the land area of Australia. So again, we are doing the U.S. over Australia. The land area of the U.S. is 9,630,000 square kilometers, and the land area of Australia is 7,800,000 square kilometers. Okay, again, I want the unit ratio. So I'm going to my calculator again here, and I'm going to take the area of the U.S., which is the 9,630,000, and I am going to divide that by the land area of Australia, which is the 7,800,000. Divide that, again, we're going to one decimal place. So 1.23, the 3 tells the 2 to stay the same, so we're just going to round that to about 1.2. So again, that means in the U.S. there is 1.2 square kilometers in the U.S. for every 1 square kilometer there is in Australia. So C, comment on your results from parts A and B. Describe what the ratio means in terms of people and land. So for the people, there are 13.7 times as many people in the U.S. Okay, but the area of the U.S. is only 1.2 times larger. All right, so we have 13.7 times as many people in the U.S. as in Australia, but the area of the U.S. is only 1.2 times larger. Moving on to part D of number 4. It says calculate a unit ratio as a decimal rounded to 1 decimal place for the population density of the United States. So if you look at the definition over here, population density of a country is the number of people per square kilometer. So we're taking the population over the area. So the population of the U.S. was 313,260,000, and the area was 9,630,000. So I want to take that as a unit ratio over 1. So again, go to your calculator. 313,260,000. And we're going to divide that by the area, which is 9,630,000 square kilometers. So again, that it's 13.52. The 2 tells the 5 to stay the same. So it's about 32.5 people for every square kilometer in the U.S. Okay. Again, that's people, and then this is square kilometers on the bottom. Okay, C, calculate the same thing for Australia. So again, we are taking the population over the area. Population of Australia was 22,870,000, and the area of Australia is 7,800,000 square kilometers. So go to our calculator. and take the 22,870,000 and divide that by the 7,800,000 square kilometers that Australia has, and we get 2.93. So again, we'll round that to 2.9 over 1. Again, that's people over square kilometers. So letter F, compare the population densities of the two countries, describe the differences. So the population density of the U.S. is greater than in Australia. U.S. has 32.5 people per square kilometer. Australia has 2.9 people per square kilometer. So it's a little more crowded in the U.S. than it is in Australia, is what that tells us. Moving on to number 5, what does it mean when two quantities are in a ratio of 1 to 1? Well, what that means is the quantities are equal. So an example to support that would be a class that has the same number of boys as girls. Okay, because again, there'd be one boy for every one girl. Number 6 says, what does it mean for two ratios to be equal? Give an example. If two ratios are equal, it means they simplify to the same whole number ratio, or they have the same unit ratio. So for example, if I took 10 over 6, that would be equal to 5 over 3, which would be equal to 1.67 over 1. If I took, say, 20 over 12, that would also simplify to 5 over 3, which would also simplify to 1.67 over 1. Okay, and then last thing here to wrap it up, or to close this out, is how are ratios and unit ratios alike and different? Well, they're alike. They both compare quantities, but unit ratios always compare to